Today I would like to show you how to do a setup, both hardware and software setup of the Pasco Universal Interface 850 is the one we use in the lab here. When you get into the lab, you want to log in with your username and password and then open up Capstone, which is the Pasco software that we'll be using. When you start up the Pasco software, you will come up with a picture that kind of looks like this. And what we need to do is we physically actually need to plug in the motion sensor too that I have sitting on a frictionless track. And there's two cords that get plugged into the digital output. The yellow stereo jack gets plugged into the first input of the universal interface, and the black one gets plugged into port number 2. Okay, you have an option also to plug in a second motion sensor, and the yellow plug in that case would be plugged into 3 and 4. If you do it the other way around, where the yellow plug gets plugged into 2, it's not going to work. Now I physically set up and plugged in the motion sensor 2. And actually, I have mine. You also have the option to do a cart or there's a wider pattern. It looks like a little person on the sensor. Just note that. And my sensor is on the track, and I might take a photograph of this. And we're gonna actually physically, we physically set up the universal interface. Now we're gonna do it's a software hardware setup. For right here. Hopefully the mouse comes out. Do the hardware setup. I click on the area where the digital interface is on the box. Scroll down, and you should see the motion sensor too. Okay. Basically, we're all done now. And for this case, for the hardware setup in the Capstone software. Now, when you opened up Capstone, you had the option of these quick templates, and they're very common templates. You can create your own templates by dragging in like a graph or a digital scope, depending on your needs, some digits, an extra table. But for right now, and check this out, I am going to use the quick start templates. I'm going to click on that. Now, the quick start template that we used here is going to have a table, and it's also going to have a graph. And we want to put the information in the table that we are collecting. And in this case, the information that I would like would be a position, okay? And I also would like possibly velocity, just to give you an example of what we're doing. Now, you have the option here also to add more columns. And you do that right up here in the very far left-hand corner, and it'll add another column. Okay? And this column will be acceleration. I'm going to add a fourth column just because it's a habit, and this one's going to be time. In this case, I like to look at the time and scroll down, and you get the time. So basically, you can make this a little bigger, make it a little smaller by moving it around just like in a normal, any normal software. It's not that much different. Okay, now we've done a table, the table here. I want to also do a graph. And you can do this before or after you run your data. It doesn't really matter. It's all in the computer when you start recording. Okay, now for example, I'm going to select this as a position versus time just to make sure everything looks nice. Okay, and my next thing is to add another graph, just to show you where it is. It's up here. It's called New Plot Area Graph Display. Okay, and that's going to click it right in the same general graph area. And I got to select the measurement, and in this case, I want to do the velocity. And you'll notice that time automatically comes up, and we can stretch it. We can reduce it, and we can do the same with the position. We can stretch it, move it around. Okay? Now, for this experiment, I'm going to actually collect less data per second, and it defaults at 20 hertz for this experiment, you can leave it at 20 hertz. Give it a try. I'm going to reduce it to 10 hertz just to collect less data and show you what's going on. Now the record button's right here, but in the meantime I have a track set up with a little frictionless cart on it. I'm going to roll that cart back to the general area and bring it kind of close to the motion sensor, and when I'm ready I'm going to release the cart and record. Stop. Okay. And you can hear the cart bouncing around a little bit, and I'm going to stretch this out over time. Bring this down a touch. Okay. Now we have a few things that happened. I can see that it's not exactly perfect. I think I have an area right here that I don't really care for, the first recording of the data, and we can actually delete that if we have to. And you would delete that area. Actually, it's an exclude, and you go up here to the yellow highlight pen. Click on the area you want to exclude. Click on the highlight pen, and move it around. Bring it in like that, and just put that right over the top there. I think I'm going to exclude 2 points for position. Now, with a right click of the mouse, you're going to exclude the highlighted area, and it actually puts X's there. It looks pretty good. Now I'm going to do the same thing for the velocity here, and I'm going to go to the highlighted area. The yellow looks like a marker pen, and I'm going to reduce that, and I'm going to take out 3 points out of that one. Okay, right click and exclude the data, and you can see it excluded the data right from the table too. Okay. So now that I have that, I wanted purposely was hoping that things wouldn't be perfect, so I could show you the fit to curve. Okay, we're going to click on the area, general area. Click on the general area right there for the position versus time, and the fit to curve. You're going to find out that that's a nice quadratic equation. Okay, and I click on it again. Oops, what's going on? Okay, quadratic fit to curve, and there we go. Okay. And you'll see that's as good as it really gets. As I move over to velocity versus time, I'm going to do the same thing. I'm going to click on the general area and then go to fit to curve, and it's a linear fit to curve, and it should look pretty good. And it actually looks really good. Now that I've taken out excluded these points here that kind of messed up in the beginning, it looks really good. Okay, you should find that a nice straight line after your fit to curve. Now I could do one other thing. I could add another graph here, and that would be a graph of acceleration versus time. And I'm going to go back up here, right here. It's the arrow points kind of 2 directions, upward and over to the right. And we're going to add that, and we can add acceleration versus time. And remember I said it was a little weird, a little strange up here in the very beginning. And I am going to exclude a couple points here, okay? And to exclude them, I'm going to click on that area, and then the highlighted pen, okay? Bring it over to create a plot of acceleration. You need 2 velocity points, so I'm actually going to exclude. Let's exclude 1, 2, 3. How about 4? There we go. We're going to exclude that data by highlighting it. Okay, and then I can also do a fit to curve, and you're going to find out that this is a frictionless track. It's not a totally friction-free track, and it's only tilted at about 10 degrees for the example I have for this video. And I'm going to click on that, and you're going to find out that the gravity acceleration is not exactly what you might think, and it's a linear fit to curve. Okay, it's not bad. Okay, this one came out pretty well. Okay, and I'm going to bring that up a little bit like that. It's not bad. And you can see the acceleration was not exactly straight across, but it was kind of slowing down. It was going faster, but it was kind of slowing down than it was from the beginning. Okay. Let me see if what else I can do on this, and I might try a second video to show you a couple extra points. I don't know how long we're into this video. There's one other little cool feature, and that's these. It's XY coordinate tool, and if I click right there and I add, it's a multi one. You have the option of a multi coordinate tool, or you have the add the coordinate tool. For this one, I'm gonna click on the multi coordinate tool, and you can actually move it around. And as you move it up and down, you can actually get the point versus the position of time, equal times over the acceleration or the velocity or the position. I kind of like that a lot. When you're going to plot the area underneath the curve, we can actually get that. I'm going to move it a little, move it a little bit and get that going. And I think in a future video, I'm going to try this one and upload this one to YouTube, and we're going to see what happens. Okay? Thank you very much. And if you have any questions, please ask. This